Today we're going to talk about what sine, cosine, and tangent are, along with the acronym SOHCAHTOA. In the most basic terms, sine, cosine, and tangent are the three basic trigonometric ratios, and SOHCAHTOA is an acronym to remember these trigonometric ratios. The acronym splits up into three parts, the first being that the sine of an angle in a right triangle is equal to the opposite side divided by the hypotenuse. Then the cosine of an angle in a right triangle is equal to the adjacent side divided by the hypotenuse, and then the tangent of an angle in a right triangle is equal to the opposite side divided by the adjacent side. These ratios can be easier to visualize. So let's say we are taking the sine of theta, and theta is just a Greek letter here we're using to represent this little angle in the corner. So the sine of theta is equal to the opposite side divided by the hypotenuse. Then the cosine of theta is equal to the adjacent side divided by the hypotenuse. And then the tangent of theta is equal to the opposite side divided by the adjacent side. So let's do some practice problems now to help us understand this a little bit more. In this first example, we're going to be looking for the sine of the angle y, the cosine of the angle y, and the tangent of the angle y from this triangle. So let's start with the sine of y. We remember from our acronym SOHCAHTOA that the sine of an angle in a right triangle is equal to the opposite side divided by the hypotenuse. So the opposite to y will be 40. And then the hypotenuse, let's remember the hypotenuse is always the side that's across from the right angle. So the hypotenuse is 41. So the sine of y is equal to 40 divided by 41. Now looking for the cosine of y, we know that the cosine of an angle is equal to the adjacent side. Now the side adjacent to y is 9. So that's equal to the adjacent divided by the hypotenuse. So the adjacent side is 9. And then the hypotenuse again is 41. So the cosine of y is equal to 9 divided by 41. And then again from SOHCAHTOA, we know that the tangent of an angle in a right triangle is equal to the opposite side divided by the adjacent side. So that'll be equal to 40 divided by 9. In this next example, we have a right triangle where one angle measures x degrees, where sine of x is equal to 4/5, and we want to find the tangent of x. So the first thing I'm going to do here is I am going to draw out a right triangle. So we have a right triangle, and we have one angle is x degrees. And then we're told that the sine of x is equal to 4/5. So I know that the sine, again from the SOHCAHTOA rules, is equal to the opposite divided by the hypotenuse. So if that's equal to 4 divided by 5, then I can say, okay, the ratio between the opposite and the hypotenuse is 4/5. So let's just for now say the opposite is equal to 4, the hypotenuse is equal to 5. So the opposite side I'm going to write as 4, the hypotenuse I'm going to write as 5. And then to find this missing side, I can just use Pythagorean's theorem. So I'm going to call this missing side just adjacent, because it's our adjacent side. So I can say our adjacent squared plus 4 squared is equal to 5 squared. Then I can say the adjacent squared plus 16 is equal to 25. So the adjacent squared, just subtracting 16 from both sides here, is equal to 9. So adjacent squared is equal to 9. And then that means our adjacent is equal to 3. So this is 3. So then I'm looking for the tangent of x. Now remember the tangent of x, the tangent of any angle in a right triangle is going to be equal to the opposite divided by the adjacent. So looking at x, the opposite is 4, the adjacent is 3. So the tangent of x is equal to 4 divided by 3. So example 3 is a little bit different to examples 1 and 2. So we're given a triangle ABC and we're given the side lengths to that triangle. And we're told that triangle ABC is similar to triangle DEF. Now remember, similar triangles means that the angles are the same. So we're told that angle A corresponds to angle D, so that means angle A has to be equal to angle D. Angle B corresponds to E, and then angle C corresponds to F. And we're looking for the cosine of F. So let's draw out triangle ABC here, just because we're given the lengths to triangle ABC. So the one thing I want everyone to take away from this problem is that side length AC is the longest. Now, if AC is the longest, that means that it has to be the hypotenuse, because the longest side is always the hypotenuse. So this side is 26 long. Now, it doesn't really matter where I put A and where I put C, as long as it's here and here, again, to make the hypotenuse side AC. So I'm just going to put the A on the top here and the C on the bottom here, but I could have put an A here and C here. It just doesn't really matter. What does matter though is now the side, or the angle opposite the hypotenuse is the right angle, and that has to be B. That's the missing angle here. So I'm also told that BC is 24, and then AB is 10. Now I know that A corresponds to D, so I'm going to write D right next to A, and then B corresponds to E, and C corresponds to F. So if I'm looking for the cosine of F, trigonometry and trigonometric ratios are just ratios. So the lengths actually don't matter. The ratios of the lengths to each other is what matters. So if we take the cosine of angle F, that is, remember with SOHCAHTOA, the cosine of an angle in a right triangle is equal to the adjacent divided by the hypotenuse. So the adjacent side here is 24. So that's equal to 24 divided by the hypotenuse, which is 26. So then simplifying this, we get 12 over 13. So let's say I had a triangle twice the size. So it's a different triangle, and I'm going to call this triangle DEF. So F is here, E is here, which is our right angle, and then D is here. So this is D. Now, I'm going to say every side length here is twice as high. So let's say this is 48, this is 52, and this is 20. So this is a triangle with very different lengths, but the angles are still the same to the original ABC triangle. So they are similar triangles. So if we're taking the cosine of F, we get just adjacent divided by hypotenuse, 48 divided by 52, which again does simplify down to 12/13. So you see, even though the triangles have different lengths, if we apply the trigonometry to the angles, we still get the same answers. For anyone wondering if this problem was on a test, we would be told that this was a right triangle. I just kind of went in and assumed that. For this next example, I kind of wanted to draw on the skills we used in that last problem and then also the previous problems. So we're told we have a right triangle, so I'll just go ahead and draw a right triangle here. And then we know that one angle measures x, so I'm going to call this angle x. And we're told that sine of x is equal to 7 over 25 and the cosine of x is equal to 48 over 50. So again here, what I want everyone to remember is from the previous problem, it's not the actual lengths that matter, it's the ratios between the lengths that matters. So that if the cosine of x is equal to 48/50, then that means that the cosine of x is also equal to 24 over 25. So now I also have that the sine of x is equal to 7/25. So we have some kind of commonality here in terms of the denominator. And of course the denominator in this case, if we remember SOHCAHTOA, is going to be the hypotenuse. So if sine of x is equal to 7/25 and the sine of an angle is equal to opposite over hypotenuse, that means that we can say the opposite is equal to 7 and the hypotenuse is equal to 25. And then now with the cosine of x, remember the cosine of any angle is equal to the adjacent side divided by the hypotenuse, and this is equal to 24 over 25. So that means the adjacent, we can say, is equal to 24, the hypotenuse is equal to 25. Now, what matters here is that the hypotenuses are the same, right? Because if I just kept it as 48/50, then I would have got a hypotenuse of 50, which would be not in common with the hypotenuse I got from the sine equation. So now I can say with confidence that the hypotenuse is 25. Now, again, this might not be the actual length of the hypotenuse of this triangle, but for the ratio's sake, which is what matters in trigonometry, I can just say the hypotenuse is equal to 25. So the opposite, I said, was equal to 7, so the opposite to angle x is 7, and the adjacent is equal to 24. And I'm looking for the tangent of x, and remember everyone, the tangent of x, the tangent of any angle, is equal to opposite divided by adjacent, so that again is from the SOHCAHTOA acronym. So if we take the opposite of x, that's going to be 7. And if we take the adjacent to x, that is going to be 24. So it will be 7/24. This next problem here is actually a pretty interesting one. It's a problem that's very similar to one I saw in an actual SAT. So let's first start just by drawing out a right triangle. And I'm going to call this bottom angle here angle x. and we're told that the cosine of x is equal to 3/5, and we want to find the sine of 90 minus x. Now, some of you may know this trigonometric identity already, but I'm just going to kind of give a proof for it. So we're told the cosine of x is equal to 3/5, and remember that the cosine of an angle is equal to the adjacent divided by the hypotenuse side. And if that's equal to 3/5, let's just say the adjacent equals 3, and the hypotenuse equals 5. So the hypotenuse is 5, the adjacent is 3. Now, I have another angle up here, and I'm going to call this angle y. Now, I also have this 90-degree angle here. So remember, all the angles of a triangle add up to 180 degrees. So that means that 90-degree angle plus y plus x equals 180. I'm going to subtract 90 from both sides, and I'm going to get y plus x is equal to 90, right? Because 180 minus 90 is 90. And then I'm going to subtract x from both sides, and I'm going to get that y is equal to 90 minus x. So if we have this 90 minus x here, and y is equal to that, instead of writing y there, I can just write 90 minus x. So I'm looking for the sine of 90 minus x. So the sine of 90 minus x is going to be the opposite side, which is 3, divided by the hypotenuse, right? Because sine of 90 minus x will be equal to the opposite divided by the hypotenuse. And in this case, the opposite is 3. The hypotenuse is 5. So it's going to be equal to 3/5. Now, some of you may have known this trigonometric identity already, but this is just kind of a proof that if you take the cosine of x, and then you get some value here, let's say you get, I'm going to call this z, you get z, and then if you take the sine of 90 minus x, the complement, you'll get z as well. And this is just kind of a proof to show that. But I've seen this problem on the SAT before, and I've actually seen kind of a variation of it on the ACT as well. For this last problem here, I wanted to choose a problem that was a little easier to imagine. So we're told that a 9-foot ladder is leaning against a wall, making a 50-degree angle with the floor. And we want to find the height of the ladder where it touches the wall. So we have a wall, we have a floor, and then we have the ladder leaning against the wall. And then we're told that it's creating a 50-degree angle with the floor. And again, we're told the ladder is 9 feet. It's 9 feet long. So this hypotenuse here is 9 feet. Right? So we have the right angle here, and we've just created a right triangle with a hypotenuse of 9 feet. And we want to find the height of the ladder where it touches the wall, which is going to be this length here. And I'm going to call this length y. So I know from our SOHCAHTOA rules, right, that the sine of an angle is equal to its opposite divided by the hypotenuse. So I know that the sine of 50 degrees here, this 50-degree angle here, is equal to the opposite side, which is y, divided by the hypotenuse, which is 9. And then just solving this equation a little bit, I'm going to multiply both sides by 9. I know that 9 times the sine of 50 is equal to y. And you are going to need a calculator for this problem, and remember that you want your calculator to be in degrees mode, not radians mode, or you'll definitely get a wrong answer. So solving this problem through a little more, we'll get 9 times, so the sine of 50 is equal to approximately 0.766. And that's equal to y. And then 9 times 0.766 is equal to about 6.894. So we know that 6.894 is equal to y. So y is equal to 6.894 feet. So thank you so much everyone for watching, and please let me know in the comments or by emailing me if you have any questions about this video or any of my other videos. And then for one-on-one tutoring, you can click on the link in the description of this video, or you can also email me as well.